We're solving problem 4 from the 2026 AIME 2. For each positive integer n, let f of n be the value of the base 10 numeral n viewed in base b, where b is the least integer greater than the greatest digit in n. For example, if n equals 72, then b equals 8, and 72 as a numeral in base b equals 7 times 8 plus 2 equals 58. Therefore, f of 72 equals 58. Find the number of positive integers n less than 1000 such that f of n equals n. Now, the first thing we want is to have 9s in our numbers, and we notice that if b is less than 10, the value decreases. However, if b equals 10, there is a 9 in the number. Now, what we can do is we can first consider two cases. One, where the number, I'm going to write num dot, has a 9. To do this, we can do complementary counting. If there are 3 digits, and each digit has values 0 to 9, and we want to exclude one number. In this set of numbers, there are 10 possible numbers or 10 digits we could have. However, we don't want a 9, so that's subtracting 1 from the 10. So we have 9 possible digits for each spot right here. So we have 9 times 9 times 9 is 729. This is the ones that we don't want, the number of cases that we don't want. However, we can do 270, or we do 1000, the total number of cases, subtract the ones we don't want, and then we get 271. And then there's this other case, case 2, where there's at least one other digit. The other digits, the other digits in this case would be 1 to 8. So then we have 8 numbers here, 8 other numbers that could go like in another spot, right? So then this is the second case, which yields just 8 numbers. So we add it to our 271 here, and then add the 8, which is equal to 279. So yeah, just to recap, there we count the number of ways where the number doesn't have 9, and then we subtract that from 1000 and add it to our second case here, which just counts 8 more from the other digits we could have. So we have 279 total cases or total positive integers n.